Hi guys, welcome to my channel. Today I'll be explaining one of the earliest and the simplest encryption technique, that is the Caeser cipher. The topics that I'm going to cover in today's video is what is Caeser cipher, what is the formula for Caeser cipher, and numerical on Caeser cipher. Before we move on to the core topic of Caeser cipher, first we'll quickly revise on the different types of encryption algorithms, which we also call as cipher. Basically, there are two types of encryption algorithm. One is called as substitution cipher and the other is called as transposition cipher. I've explained these two ciphers in detail in my previous video, whose link is given in the description. So what is the difference between these two ciphers? Substitution cipher is a cipher which basically replaces or substitutes each character of the plaintext with totally another character, while a transposition cipher is a cipher or encryption algorithm which reorders the positions of the characters present in the plaintext. So coming to the main topic, what is Caeser cipher? So Caeser cipher is basically a substitution cipher, and hence it is going to replace each character of the plaintext by another character using the encryption. Now, why is the cipher called as Caeser cipher? Because Caeser cipher is named against Julius Caesar, who apparently used this method to send secret messages to his followers and protect these messages from the enemy. Let us now have a look at the formula or algorithm which is used for Caeser cipher. Let us represent plaintext as P. Let us represent key as K, which is a number between 1 to 25, and let us represent the ciphertext as C. So the Caeser cipher encryption algorithm will take the inputs, that is the plaintext P and the key K, and generate the ciphertext C. He will generate the ciphertext C using the encryption algorithm P plus K mod 26. Now coming to the question, why is Caeser cipher using mod 26? Because our plaintext P is basically made of letters from A to Z. That is, we have a total of 26 letters. That is, if I map A to number 0, B to number 1, C to number 2, D to number 3, and so on and so forth, Z will be mapped to number 25. So we are working on a finite field of 26 numbers, with numbers ranging from 0 to 25. Since the Caeser cipher encryption algorithm works on plain text which represents any number within the finite field of 26 numbers, we use mod 26 in the encryption algorithm. Now this ciphertext is then transmitted to the other end to the decryption algorithm. So the decryption algorithm will receive the ciphertext C, he will receive the key K, and he will generate the plaintext P. So what is the formula used to generate the plaintext? The formula to generate the plaintext is given as C minus K mod 26. So with this, let us quickly revise on the formulas that we learned. So if P is the plain text, K is the key, and C is the ciphertext, the encryption algorithm for Caeser cipher is given as P plus K mod 26, while the decryption algorithm used by Caeser cipher is P is equal to C minus K mod 26. Now note that the key that is used here is a number between 1 to 25. Why is it so? Because if you use the key K as 0, the ciphertext that you get will be the same as plain text, and hence you will not get any encryption. So if K is equal to 0 does not lead to any encryption. Moreover, the key that is used in these ciphers are similar keys, that is, the sender as well as the receiver both uses the same number as the key. So Caeser ciphers are basically symmetric ciphers which uses the same key. Also, in order to ensure the security of the ciphertext, in order to ensure that it is secure from the attackers, the key has to be kept a secret. So the key should not be revealed to anyone else other than the sender and the receiver. Only the encryption algorithm used by the sender and the decryption algorithm used by the receiver should know the key, and no one else should know the key. Only and only if the key is secure, the encryption algorithm ensures the security of the secret message P that you are sending. Because Caeser cipher makes use of addition, they are also known as additive ciphers. Let us now move on to solve some numericals. Let us say we have been given this question: encrypt the given plaintext Caeser using the key as 3. We can generate the ciphertext using plaintext P plus K mod 26. The key is given as 3. Now what is the plaintext that you will use? Because the plaintext that they have given here is CEASCR. They are made up of letters. Now we have to map these letters to numbers. In order to do that, we use a table which maps the letters to numbers. So we take all the letters and we map the letters, that is from A to Z, to numbers. Like A is mapped to 0, B is mapped to 1, C is mapped to 2, D to 3, E to 4, F to 5, and so on and so forth till the Z is mapped to number 25. So the first step of solving any scissor cipher question is that you map each of the letters to numbers so that you know the number corresponding to each letter of your plain text, so that it can be processed by the addition formula of your scissor cipher. So the first step is that we use this table where each letter is mapped to the number, so that the letters in the plain text is mapped to the number. For example, C will be mapped now to number 2. The letter E will be replaced by number 4. Letter A will be replaced by number 0. The letter S will be replaced by number 18. The letter E will be replaced by number 4. R will be replaced by number 17. So our plain text which we want to encrypt will be number 2, 4, 0, 18, 4, 17. So each of these numbers will be now processed by using the additive algorithm, which is P plus K mod 26. So it is clear from this table that since we are working over a finite field ranging from 0 to 25, we are working on a total 26 letters, that is 26 numbers. We make use of mod 26. So the moment the number exceeds 26, we have to bring it back within the range of 0 to 25. Therefore, we use mod 26. Coming back to the question where we wanted to encrypt the word scissor using the key 3. So the first step, as I told you, you have to make use of this mapping table. Then the second step is you make a 3-column table where the first column represents your plain text. So you write down the plain text here, that is C, E, A, S, E and R. Now in order to encrypt, you are making use of mathematical formula P plus K. So you need numbers corresponding to C, E, A, S, E, R, plain text letters. So for this we make use of this mapping table. So what is the number corresponding to C? It is 2. So you replace C with 2. What is the number corresponding to E? It is 4. So write 4. What is the number corresponding to A? It is 0. So your plain text number is 0. What is the number corresponding to S? It is 18. So write the number 18. So what is the number corresponding to E? 4. What is the number corresponding to R? 17. Now these numbers are processed by your encryption algorithm with the formula P plus K mod 26. And what is K? K is 3. Now in the second column we'll do the mathematics used by the encryption algorithm. Basically we are using modular arithmetic. Those who don't know modular arithmetic can check out my previous video where I've explained modular arithmetic in detail. The link is given in the description box. However, here in short I will explain it again. So we want to encrypt C, and the number corresponding to C from the mapping table was 2. So this number 2 is now processed by adding it with the key. The key is 3 as given here, mod 26, which basically is 5 mod 26, and since 5 is less than 26, the resultant answer of 5 mod 26 is 5. The second number which we want to encrypt is 4. Add the key K is equal to 3 to it, mod 26, which comes out to be 7 mod 26. Since 7 is less than 26, the resultant answer is, the next plain text is 0 plus 3 mod 26, which comes out to be 3 mod 26, and since 3 is less than 26, it will be as it is. 18 plus 3 mod 26 plus 3 is 21 mod 26, and since again 21 is less than 26, you will keep it as 21. Next letter is 4 plus 3 mod 26. So every time in the computation we have added the key. Key is 3. So to the plain text letter we have to add the key, that is 3. So 4 plus 3 is 7 mod 26. So you have to check if it is less than 26, you retain it as it is, but if it exceeds 26, then you have to do modular arithmetic. Let us see for number 17. So 17 plus 3 mod 26, which is 20 mod 26, and since 20 is less than 26, we keep 20 as 20. So since all our numbers that we got for modular arithmetic operation operation were below the modulus number, and hence we have retained it as it is. We don't have to perform modular arithmetic here. But in case where the resultant number exceeds 26, you have to use modular arithmetic and bring the number within the range of 0 to 25. Okay, I shall cover such an example in my next video. As of now, the resultant numbers for ciphertext that we got is 5, 7, 3, 21, 7 and 20, for which we have to find the corresponding letters of the ciphertext. So in order to find out the letters corresponding to each of these numbers, we would require the mapping table again. So we'll use this mapping table again to map the numbers for the ciphertext to the letters of the ciphertext. So let us see the first case. 5 maps to letter F. So my first ciphertext letter is F. The number 7 map to letter H. So my ciphertext letter is H. Number 3 we got a ciphertext number map to letter D. 21 map to letter V. 7 map to letter H and 20 maps to letter U. So these are the final ciphertext letters that we got, and hence our plain text which was given as Caeser has now been converted into the ciphertext as FHDVHU. So this is my final answer of encrypting the letter Caeser. Let us now check out the example of decrypting this particular word and recovering the plain text back. So we are asked to decrypt the given ciphertext using the key 3. So decryption is basically used to recover the plain text. What is the decryption formula? The decryption formula is you have to take the ciphertext, subtract the key and do it using mod 26. Now we have to decrypt these letters, so we want to map the letters into numbers. You know the mapping table now. In the first step we'll use the same mapping table. In the second step you create this 3-column table, where in the first column you will write down the letters of the ciphertext, that is F, H, D, V, H, U. We now assign number to each of these letters of the ciphertext from the mapping table. So F corresponds to number 5, H corresponds to number 7 in the mapping table, D corresponds to number 3 in the mapping table, V corresponds to number 21, H corresponds to number 7 and U corresponds to number 20. Now the decryption algorithm will take the number 5 and subtract the key. What is the key? 3, and do modular arithmetic of mod 26. So 5 minus 3 is 2 mod 26. Again 2 is less than 26, so my final answer is 2. So my plain text number that I got is 2. In the second case, the ciphertext number 7 is subtracted with the key 3 mod 26. 7 minus 3, 4 mod 26. The resultant number is 4. So a plain text number that we recovered is 4. So the next letter is D, whose corresponding number from the mapping table is 3. Do 3 minus the key which is 3 mod 26. So we get 3 minus 3 as 0 mod 26, and since 0 is less than 26 it remains 0. So my plain text number is 0. The next letter was V. From the mapping table I got the number 21. So we do 21 minus the key which is 3 mod 26. So 21 minus 3 is 18 mod 26. So 18 is a number which is less than 26, and hence his final answer remains 18. So the plain text number which we get is 18. Now the next letter was H. The number corresponding to letter H in the mapping table was 7. So we are doing decryption. So we have to subtract the key from it. What is the key? Key is 3. So 7 minus 3 mod 26. 7 minus 3 is 4 mod 26. And 4 is a number which is less than 26. Therefore 4 mod 26 is 4. So plain text number which we recover is 4. The next letter was U. The number corresponding to letter U from the mapping table was 20. So we take the plain text number 20, deduct the key which is 3 from it. So 20 minus 3 is 17 mod 26, and since 17 is a number which is less than 26, it remains 17. So the plain text number which we have recovered is 17. Now having recovered these plain text numbers, we now have to convert these numbers into its corresponding plain text letters, for which we would require a mapping table again. So we refer to this mapping table and recover the letters corresponding to each number of these plain text. So number number 2 corresponds to alphabet C, number 4 corresponds to alphabet E, 0 corresponds to alphabet A, 18 corresponds to alphabet S, 4 corresponds to alphabet E, and 17 corresponds to alphabet R. So as you can see here, for the cipher text given as FHDVHU, we have recovered our plain text as scissor. So we have recovered the plain text back. So in this video, I have kept the key, which is 3. So our modular computation was very simple, but in my next video, I'm going to take another example. In this video, I just wanted to introduce the concept of Caeser cipher and some easy numerical on Caeser cipher. In my next video, I'm going to take another example on Caeser cipher where I'll be using modular arithmetic to solve complex computations for Caeser cipher. So I hope you guys understood my explanation. Kindly comment if you understood. Also comment if you did not understand so that I can improve myself accordingly. So see you guys in the next video. Stay healthy, stay happy, stay blessed.